In this section, we shall be discussing the aircraft's braking system. We shall see that two systems exist for braking purposes, a normal system and an alternate system. The relationship between flight deck brake controls and system operation will be looked at. We shall also be discussing the anti-skid system, which provides automatic control of the brakes to prevent aquaplaning or skidding. The purpose of the accumulator will be outlined and its role in supplying reserve braking pressure described. We shall locate and describe the flight deck indicators for alternate brake system pressure and also for brake temperature values. The significance of particular indications will be examined. The operation of the automatic brake system will be explained with particular reference to how it is engaged and disengaged. Finally, we shall be describing those malfunctions which may occur in the braking system. The flight deck alerts will be discussed and the appropriate procedures presented. The aircraft has two braking systems, comprising a normal system, which receives hydraulic power from the number 2 system, and an alternate system, which receives its power from the number 1 system. Each pilot's rudder pedals are fitted with brake pedals. The captain's and first officer's pedals are linked together, and therefore moving one set of pedals will cause a corresponding movement in the other set. Pressing down on the left or right pedal operates its respective brake control valve. This may be a normal or an alternate brake control valve, depending on which pressure system is operating. Springs return the pedals to the off position and also provide a feel sensation for the pilots. The parking brake on the flight deck is linked to the parking brake shut-off valve. This valve is located in the alternate system return line. From the brake control valves, hydraulic pressure goes to anti-skid valves. Please note that the normal system has a separate anti-skid valve for each wheel, whereas the alternate system uses only one anti-skid valve for each pair of wheels. Hydraulic fuses are fitted in the supply lines to each brake unit. If a supply line should develop a leak, the hydraulic fuse will operate and will stop fluid flow, thus isolating the leak. Shuttle valves are also fitted to each of the brake unit supply lines. A brake unit is fitted to each main wheel. The brake discs are made of carbon fiber and each unit is self-adjusting. Brake wear is indicated by a pin that protrudes above the brake housing. If this pin is level with the housing, the brakes require maintenance. The brake units are also fitted with a thermocouple which allows brake temperature to be measured. The brake temperature indicators on the first officer's instrument panel show the individual wheel brake temperatures. Within the hubcap of each main wheel is a speed sensor for the anti-skid system. The auto changeover valve ensures that number 2 system supplies hydraulic power under normal conditions or switches to number 1 system if the pressure drops in number 2 system. The alternate system has an accumulator fitted to provide a reserve hydraulic pressure for alternate brake operation. The alternate brake system pressure indicator on the first officer's panel receives data from a pressure sensor located in the alternate system. An automatic braking system is fitted and is controlled by a selector on the center instrument panel. This may be used as an alternative to the manual system. That completes the section on description. We shall begin our discussion of operations by looking at the normal system. The pressure of the normal system is 3000 psi. At this pressure, the auto changeover valve ensures that the normal brakes are in operation and receive hydraulic power from the number 2 system. Depressing the brake pedals will then operate the normal and alternate brake control valves, but pressure will only be felt at the normal control valves. The further the brake pedals are depressed, the greater the braking pressure. When the brake pedals are released, pressure within the brakes is also released and fluid is pushed to the number 2 system return lines. Should the number 2 system pressure fall below 1,500 psi, the auto changeover valve operates and system number 1 supplies the pressure for brake operation. Depressing the brake pedals now operates the alternate brake control valves. Please note that the same brake units are operated by the normal or alternate brake systems. Shuttle valves at the brake units allow either number 1 or number 2 system pressure to be used. A pressure sensor is fitted to the alternate system. During normal operation, this will show a normal system number 1 pressure of 3,000 psi. As we have seen, the alternate system also has an accumulator. The accumulator is normally kept fully pressurized from the number 1 system at 3,000 psi. The unit is pre-charged to a pressure of 1,000 psi. Should the number 1 system fail, a non-return valve will prevent the accumulator pressure from being released into the system. The stored pressure in the accumulator can be utilized for up to 6 applications of the brakes. We shall now consider parking brake operation. The parking brake is set by depressing the brake pedals, pulling the parking brake handle, and then releasing the pressure on the brake pedals. The handle will remain in the up position. To release the parking brake, the brake pedals are pressed, and the handle will then return to the down position. When the parking brake is set, it operates the parking brake shut-off valve to the closed position. Information is also sent to the takeoff warning and status information circuits. A blue memo message, Park Brake Set, appears on the top left MFDU, and the status page is automatically displayed on the right MFDU. The parking brake shut-off valve is located in the number 1 system return line. This means that if pressure is not available from number 1 or number 2 systems, the parking brake can use stored pressure from the accumulator. We shall now consider the anti-skid system. The dual skid control valves are controlled by the skid control box. The skid control box has input signals from the wheel speed sensors fitted in each wheel hub, ground flight information, and power on or off information. The skid control box provides a touchdown protection circuit. With the aircraft in flight, the anti-skid valves will not allow brake pressure to the brake units. This makes landing with the brakes on impossible, thus preventing tire blowouts. A locked wheel protection circuit provides protection against the possibility of aquaplaning after landing. Once again, the anti-skid valves prevent pressure at the brake units until the wheels are in contact with the ground and the wheel speed sensors have detected positive wheel rotation. Finally, a skid detector circuit becomes active when positive wheel rotation is detected. This allows braking to be applied to the point of the skid threshold. The anti-skid valves prevent the threshold being exceeded, thus giving maximum braking efficiency when needed. To check the anti-skid test system, a test button is provided on the test panel. When the anti-skid test button is pressed, a white anti-skid light will illuminate if the system is serviceable. The light will extinguish when the test button is released. The final discussion in the operations section will deal with the automatic brake system, or ABS. Control of the ABS is by means of a 5-position rotary selector on the center instrument panel. Selecting the desired position arms the system. Please note the ABS will not arm if faults are detected in the ABS system, the anti-skid system, or the number 2 hydraulic pressure system. The RTO, or rejected takeoff mode, can only be selected on the ground. RTO mode becomes active if During takeoff, the thrust levers are retarded to idle and ground speed is above 80 knots. Maximum braking will then be applied until either the aircraft comes to a halt or the system is deactivated. The pilot can deactivate the system in the RTO mode by operating both brake pedals, or advancing either thrust lever, or by turning the ABS selector to off. Deactivate the system by advancing the thrust lever. When the system is deactivated by advancing either thrust lever or by operating both brake pedals, the selector knob moves to the off position. The low, medium and high ABS selections can only be selected when the aircraft is in flight. Each of these three positions define different levels of deceleration. ABS meters brake pressure to obtain the desired deceleration level. With either of these modes selected, the ABS is activated after touchdown when both thrust levers are retarded to idle. During the landing, another braking mode can be selected at any time by rotating the selector to the desired position. Please note that the system can be deactivated by using the same procedures as in the RTO mode. That concludes this section. In looking at non-normal operations of the braking system, we shall initially consider high brake temperatures. Brake temperatures are shown on the brake temperature indicators on the first officer's instrument panel. If the needles show temperatures in the yellow sectors or above the red marker, the brake temperatures are too high. The appropriate procedure for this malfunction is shown in the QRH. Please note that if one brake shows a significantly higher temperature than the others, this may indicate a brake malfunction. The parking brake should not be used if brake temperatures are high. If brake temperatures remain excessive for extended periods of time, the wheel temperature could also become extremely high and result in a tire blowing out. To prevent this, each wheel has 3 fusible plugs which cause the tire to deflate in the event of prolonged high temperatures. If a fault occurs in the anti-skid mechanism, a level 2 alert occurs on the flight deck. The left MFDU displays the anti-skid message. The procedure is displayed on the right MFDU. Please note the alert inhibition. The QRH supplies appropriate advice for this alert. The last malfunction that we shall discuss concerns the automatic brake system. If a fault occurs in the ABS, a level 2 alert occurs. An amber fault indication also appears in the auto brake fault light. Check the MFDS to verify the alert and for the correct procedure. Please note the alert inhibitions for this malfunction. The stated procedure is to rotate the ABS selector knob to off. Please note this procedure only applies if the aircraft is airborne. Finally, the QRH should be consulted for any additional information regarding an auto brake fault. In this module, we have looked at the main components of the braking system. In this respect, we have shown that the brakes can be operated by pressure from one of 2 systems. A normal system which receives pressure from the number 2 system, or an alternate system which uses number 1 system pressure. Both have a pressure of 3000 psi. It was stated that each pilot's brake pedals are fitted to the rudder pedals and that pressing these pedals operates the brake control valves. The parking brake was located and its operation described. We looked at the anti-skid system and noted that the normal system uses a skid control valve for each wheel, whereas the alternate system uses 1 skid control valve for each pair of wheels. The purpose of the hydraulic fuses in isolating fluid leaks was explained. It was stated that if the number 2 system pressure drops to less than 1500 psi, the auto changeover valve operates to switch braking pressure to the number 1 system. We described the purpose of the accumulator and noted that it stores sufficient pressure for 6 applications of the brakes. We located the alternate brake system pressure indicator. The brake temperature indicators were also located and the significance of particular indications explained. It was stated that the automatic braking system is controlled by means of a 5-position selector. The purpose of each selector position was explained. Finally, we looked at malfunctions in the braking system. We noted that these apply to brake temperature, the anti-skid system, and faults in the auto brake mechanism.